Solving linear inequalities and inequality applications.
Solving inequalities logical path. Mathematics presents real world, and if something does not work in real world, it would not work in mathematics. Let's look into 3 options where you can see 2 baskets on the scale, and left basket for each option has 4 apples, 3 red and 1 green. Difference in second basket. Let's look into first option. 4 apples on the left and 3 on the right, and sure, left basket is heavier. What about second option? 1 basket has 4 apples, but second has much more, and our scale show opposite. Scales show that left basket is heavier. So it's wrong. Presentation is wrong. And third option. Left basket has 4 apples and right basket has 3 apples. Everything is fine. Now, if we show red apples in the left basket as an x, then from the first option we will have inequality x and positive 1 is greater than 3. And solution will be x is greater than 2. So we have to have more than 2 red apples on the left. Now let's look into inequalities for the second situation, which we remember is wrong. X and positive 1 is greater than x and positive 3. So this inequality is wrong because this inequality presents wrong statement, wrong situation. This is why this inequality would never ever have a solution, because it's false statement. Third situation. What do we have here? X represents number of red apples. On the left, we have always 1 apple more than we have on the right. So it's always true. If it's always true, then solution set is the set of all real numbers. On the next slides, we will talk about these 2 last situations with more details.
Modeling for example number 2. If we have 2 baskets and a left basket has 3 apples and right basket has 2 apples, so it's clear that these 2 baskets can't be in balance. This is why if we replace 2 red apples by x, then we will have an equation x and positive 1 equal x. And this equation is wrong because this equation represents wrong situation from the beginning. So we assume that this equation wouldn't have a solution. But inequality, if we have 2 baskets and left basket has 3 apples and right basket has 2 apples, and it's clear that left basket is heavier, as it's supposed to be. Now, if we replace 2 red apples by x, we have an equality x and positive 1 is greater than x. Is it true or not? What do you think? Now let's use algebra to solve equation and inequality. We have to separate terms with x and constant terms, and then we will simplify. So we will move positive 1x from the right to the left and positive 1 from left to the right for equation and for inequality. For equation, we will have negative 1x and positive 1x equal negative 1. For inequality, negative 1x and positive 1x greater than negative 1. Now simplifying equation 0 equal negative 1, and for inequality 0 is greater than negative 1. Now for equation 0 equal negative 1 is false statement, so this equation doesn't have solutions. Set is empty. But for inequality, let's talk. 0 greater than negative 1. Is it true or not? Sure, it's true. So we have to say the solution set is the set of all real numbers. And we can show this set building notation in R. R stands for all real numbers. Now I can show you all types of answer which could be for this particular inequality. On real number line, you can see solid line which is going from negative infinity to positive infinity. All real numbers. Inequality. X is greater than negative infinity and less than positive infinity. Set builder. We have to copy inequality. And then interval. You have to show negative infinity, positive infinity, and parentheses around. Modeling can help us to understand our answer better. Look, if we add one apple to left basket and one apple to right basket at the same time, so now we have 4 apples and 3 apples. Left side is heavier. If we add one more apple to both sides, then we will have 5 and 4. Left side is heavier. If we add more, it will be 6 in left and 5 in right. Again, left side is heavier, regardless of number of apples which we are going to add to both baskets at the same time. It will be always true, because the left basket has one more extra green apple always. This is why we can say for inequality, x and positive 1 is always greater than x. If x is 0 on both sides, then 1 is greater than 0. If x is 10, then 10 and 1 would be 11, is greater than 10. If x is 100, then left side would be 101, and right side is just 100. So left side is always greater than right side in this case, because left side has 1 unit more. This is why we have to say solution for this inequality. All real numbers for any number for x. You can pick 1 billion for x. Then left side would be 1,000,000,001. Left side is greater than right side because right side would be just 1 billion. Now practice problem. We have an equality positive 1x and positive 6 greater than positive 1x and negative 4. We have to solve for x. We will do exactly as we would work with equations. So we have to separate terms with x and constant terms. And then we will simplify. We are moving positive 1x to the left and positive 6 to the right. As a result, we will have negative 1x and positive 1x on the left greater than negative 4 and negative 6. Simplifying, negative 1x and positive 1x, 0. Negative 4 and negative 6, negative 10. Now, what we have, 0 is greater than negative 10. Is it true or not? It's true. This is why we have to say the solution set is the set of all real numbers. you can show this as set builder notation NR, which stands for all real numbers. Or you can show this as a graph, solid graph, which is going from negative infinity to positive infinity. Inequality, x is greater than negative infinity and less than positive infinity. Set builder, so we just need to copy inequality and interval from negative infinity to positive infinity. One more example. This time we have fractions. X over 5 and negative 4 is less or equal to positive 3. So we have to clear fractions as we would do working on equations. So we have to find the least common denominator for all denominators. In this situation, it's just 5. So we have to multiply each piece on both sides by 5. By 5, by 5, by 5. And simplify. 5 over 5 is 1. As a result, we will have positive 1x and negative 20 less or equal to 15. Separate terms with x and constant terms. Sure. Negative 20, we are moving from the left to the right. And now we need to combine like terms, 15 and 20, so x is less or equal to 35. Now we know a different type of notation for the answer, but this time I decided to use graph. So from 35 we are moving to negative infinity. So all numbers from negative infinity to 35, all of them, they are solution of this inequality. Next example. X over 3 and 5 over 2 less or equal positive 3 and x over 2. We have an equality with fractions, so we have to find the least common denominator for all denominators, which is 6. So now we are multiplying both sides by 6, by 6, by 6, by 6. We want to clear fractions, so this is why we have to simplify now. 6 over 3 is 2. 6 times 5 over 2 is 15, and 6 over 2 is 3. Now we have equivalent inequality without fractions. Positive 2x and positive 15 is less or equal 18 and positive 3x. Now let's separate term with x and constant terms. So positive 3x moving to the left and positive 15 we are moving to the right. Don't forget to change signs. And now let's simplify because we have like terms on the right side and like terms on the left side. Negative 3x and positive 2x would be negative 1x, and positive 18 and negative 15 would be just 3. As a result, we have negative 1x is less or equal to 3. We are looking for positive 1x, so we have to divide it by negative 1. Don't forget to flip the sign of inequality because we have to divide it by negative. So as a result, we will have positive 1x is greater or equal to negative 3. Now we can use graph and show x is changing from negative 3 towards positive infinity. So all numbers from negative 3 to positive infinity, they are solution of this inequality. Next problem. X over 3 and 5 over 2 greater or equal than positive 3 and x over 2. We have to clear fractions, so we have to find the least common denominator, which is 6. We are multiplying both sides by 6, by 6, by 6, by 6, and simplifying. 6 over 3 is 2, 5 times 6 over 2 is 15, 3 times 6 18, and 6 over 2 is just 3. Now we have equivalent inequality, but without fractions. We have to separate terms with variables and constant terms. 3x moving to the left and 15 to the right. As a result, we have negative 3x and positive 2x greater or equal 18 and negative 15. Simplifying, negative 3x and positive 2x, negative 1x greater or equal 3. Now let's divide it by negative 1. Remember, by negative. So we have 2, flip the sign, and then negative 1 divided by negative 1 would be positive 1x or just x. 3 divided by negative 1 would be negative 3. So our answer is x is less or equal negative 3. This time I decided to use set builder notation. So all solutions for this inequality are between negative infinity and negative 3, because x is greater than negative infinity and less or equal to negative 3.
Solving word problems require inequalities. Logical path. Practically, if you have to work with inequalities, you have to use the same step if you would use to write in equations. But I will give you one hint. It's easy to write an equation first, even though problem would be about inequalities. Only and only on the last step, change symbol equal by the symbol of inequality. Less, more, or less or equal, or more or equal. And then just solve using inequality.
Word problem. Tom has received score of 86 and 88 and 87 and 83 on his algebra tests. What is the minimum score he must receive on the fifth test to have an overall test score average of at least 88? Hint: the average of the list of numbers is their sum divided by the number of numbers on the list. Analysis. We are looking for minimum score for test number 5. Number of tests, total number of tests is 5. Score for the 4 first tests: 86, 88, 87, 83. And we are looking for the score for test number 5. This is why we have to mark this as an X. Now, we know from the problem that average is supposed to be greater or equal 88. Step number 2, we are writing and solving an equation or inequality. Numerator, we have to add all score for all tests, known and unknown, and divide it by the total number of tests. So our numerator is 86 and 88 and 87 and 83 and x, and we have to divide it by total number of tests, which is 5, and all of this is supposed to be greater or equal 88. Now we just need to solve this inequality. We have to clear fractions, so we will multiply both sides by 5 and simplify. 5 over 5 is 1, and then we will have just 344 and x greater or equal 440. 344 we get adding all tests score, and 440 we are getting from 88 times 5. Now we just need to solve this for x, moving 344 from the left to the right and simplifying. So x is greater or equal 96. Now checking. We have to replace x in original inequality by 96 and check, is left side equal to right side? Yes, 88 is greater or equal to 88. Now we can write the answer. Minimum score for test number 5 is 96. Good luck, Tom. Next problem. When making a long distance call from a certain payphone, the first 3 minutes of a call cost $1.50. After that, each additional minute or portion of a minute of that call cost 30 cents. Use an inequality to find the maximum number of minutes one can call long distance for $5.10. So we are looking for maximum number of minutes for $5.10. And we have to use the same units for money. We are going to use dollars. Analysis. As you see from this problem, first 3 minutes cost $1.50. After that, each additional minute cost 30 cents. Additional minute after first 3 minutes. Then, if you mark as the x time in minutes, which can someone use for $5.10, then number of additional minutes would be x minus 3, because we have to subtract first 3 minutes. We pay for them for $1.50. Now, the total cost of that call is supposed to be $5.10. Not more. It can be only and only $5.10. But number of minutes can be maximum or it can be less. Now we are ready to write an equation or inequality. Let's look into this inequality. You can see that this inequality represents money in portions. Left side, $1.50, this is money for first 3 minutes. And then second piece would be money which someone's supposed to pay for additional time after first 3 minutes. This is left side. And right side, the total cost, which is $5.10. Now we have to work on this inequality without reference to money. Just work as algebraic inequality. We have to remove parentheses using the distributive property first. After that, we have to combine like terms, because 150 and 0.90 together is 0.6. Next step would be we have to separate terms with variable and constant terms, so we are moving 0.6 from the left to the right, and it's becoming negative 0.6 on the right. Next step, we have to combine like terms, so 5.10 and negative 0.6 would be 4.5. We have to find 1x or just x, so we have to divide it by 0.3 both sides. And because we have to divide it by positive, so we don't need to flip the sign. So x is less or equal 15. Next step would be checking. In our original equation, we have to replace x by 15 and check, is left side less or equal to right side or no. Use your calculator and you will see 5.10 equal to 5.10. And we can accept this answer because our inequality allows two answers. It's supposed to be less or equal. We check equal. Now write in the answer. Question was maximum number of minutes for $5.10. So if you have $5.10, you can talk only and only 15 minutes, not more. But if you wish, you can talk less. This is what our answer shows. The maximum number of minutes is 15.